Hello everyone, welcome to Wallah English YouTube channel. I hope everyone is doing great. So till last lecture we have covered basic introduction of hydrology. Okay, what is like why we are studying hydrology and what is water budget equation, what is water cycle. We have studied all the topics. Okay, and in today's class we are going to start precipitation, and basically we'll discuss like why precipitation occurs, what are the basic causes behind it, what are the different types and forms of precipitation that we are going to deal today. Okay, before starting, everyone kindly comment if my audio is fully uh, clear to you all. Am I fully audible and visible to you all? Kindly comment once. After that we'll start. Okay, kindly comment everyone and share the session with everyone. It will be a very great session for you all. In today's lecture we are going to discuss about precipitation. Okay, before moving ahead, let us take a quick recap of what we have covered till now. Okay, so we have started from the very basic syllabus. I told you that we will be covering hydrology in this sequence only. We will cover these topics one by one, and today we are going to start with our chapter 2, which is your precipitation. Okay, then we discussed like what is hydrology in general sense, what are the objectives of studying engineering hydrology, that I have already told you. After that we went to what is the total amount of rainfall that is being received by Indian subcontinent and how much amount of water we are able to utilize, that we have discussed. I hope it is clear to you all. After that we discussed how much is the total volume of water which is present in the world globally, which is present, and how it is distributed, how much water is present in India, that also we discussed. This was the basic distribution of water which we have already discussed. You should remember one point, that around 70% water is frozen and around 30% water is in ground. Okay, so this we have already discussed. Then we discussed the basic water cycle, the hydrological cycle, which is driven by sun. Okay, sun's energy is there, because of which you all know this cycle is happening. And I told you in this cycle we have three basic phases. The very first one was evaporation, then precipitation, and after all the losses takes place we have runoff. I already told you. So this is the basic cycle in which we discussed many phases. Okay, we discussed evaporation, precipitation was there, infiltration was there, percolation, transpiration, then depression, storage, varga, interception, runoff, all sort of phases we have discussed in this. Okay, so after water cycle we discussed different phases and why it is being caused. You have to remember that water cycle is being caused because of the sun's energy. Okay, sun is the driving force because of which this cycle is being driven. Okay, then we went on to catchment area. Like what is catchment area, what is watershed, what is basin, sink, all are one and the same, that we have discussed. So firstly I told you about the ridge line, the watershed, the divide line. Okay, water divide line. So it is the highest line and the lowest line is your valley line. Water starts flowing from highest line to the lowest line. All the water which is falling into this catchment area will ultimately drain into the main stream and ultimately reach the outlet. Okay, and the amount of time which is required to reach the outlet depends on what sort of catchment it is, what is the shape, what is the size, that we have already discussed. Okay, and I also gave you example of Ganga catchment area, a very huge catchment area which is present in this Gangetic plain is basically your Uttarakhand, UP, Bihar region. Okay, as you can see in this diagram. Okay, now after this we have discussed catchment leakage. Okay, what was catchment leakage? I already told you. Catchment leakage basically occurs when the surface divide and the groundwater divide are not coinciding. Okay, then you can see that whatever water is falling in one catchment area can leak into another if the line is not coinciding. Okay, I explained it to you. Then after this we went on to runoff coefficient. It was very simple. Simply the ratio of runoff to rainfall is nothing but your runoff coefficient. Okay, it simply indicates the land use pattern. Okay, depending on the land use, okay, what sort of how our land is being covered or what type of land pattern is there. You all know that land can be fallow or it can be road construction can be there, or any kind of construction can be, forest can be there. Okay, basically 9 to 10 types of land uses are there. Depending on that, runoff depends. Okay, I told you when we have different zones, different areas are having different runoff coefficients, then how we find equivalent runoff coefficient, I told you formula, and I also made you to solve one question. I hope you all remember it. Then we discussed water budget equation, which is nothing but inflow minus outflow equals to delta S, and I also simplified it for surface and subsurface. Then final equation which we have, you have to remember it. This is very important equation. Kindly comment once, then after that we'll move ahead. Okay, we'll try it now. We'll try, don't worry. First, kindly comment the basic water budget equation formula. PRGET equals delta S. Okay, P equals precipitation, delta R is net runoff. Then we have delta G, which is net groundwater flow. Then we have E, which stands for evaporation. T stands for transpiration. Okay, so this is your water budget equation. For longer durations, you all know delta S equals 0. For larger catchment area, delta G equal to 0. This I have already told you. Then the final simplified equation was, which was left here, was P minus losses equals net runoff. Okay, so after your precipitation, all the losses will occur, and after losses have happened, then you will see runoff will take place. Okay, this is your net runoff. So this equation is the simplified version of water budget, which you have to remember. Based on this, we are going to subsequently discuss the upcoming 3 chapters, which is your precipitation, the first one, then losses from precipitation, the third one, and then your runoff. Okay, these are the 3 chapters which we are going to discuss. I also solved some questions. I hope you all remember that. Okay, we have solved it in exam in class itself, so I hope you remember it. So these were the questions which were based on your water budget. Okay, I also gave this question in homework. I hope you have solved it. The answer to this question was how much. Have you solved it or not? Have you solved it? The answer to this question was how much? I hope you have solved it. Wait a second. Do you remember how much is the answer which you are getting? Yes, the final answer which we are getting here is delta Z will be, when you'll solve it, you will get delta Z equals 0.058 meters. Okay, this is the answer which you will get from after solving this entire equation. I already told you which values you have to substitute here. So 0.058 meter is the answer, and then the final elevation will be what? 103.2 is the level of water initially in the starting of the month. So finally the level will be what? 103.2 plus this, because water level will increase. Okay, so final level you can evaluate after 1 month. Then we solve another beautiful question with the help of which entire runoff concept, I hope, must have been clear to you. Yes or no? Yes, 103.258. Brilliant, perfect answer. So this you have already solved. Then we have discussed one runoff question. I hope this is clear to you. So in today's lecture, we are going to basically discuss what are the causes of precipitation, what are the types and forms of precipitation. This is the ultimate goal of today's class that we'll discuss. But before moving ahead, first let us solve some questions. Okay, because you all know that questions are you can say questions generally comes in exam, so we have to practice a lot so that we become swift in it. Okay, so in order to achieve that speed and accuracy, we have to practice some questions. So today, before moving ahead, we are going to solve some 3 to 4 questions, and then we will proceed with today's topic. Okay, because I want to make this video lectures holistic in nature, or you can say complete. So that's why I'm putting efforts in solving questions in live class itself. Okay, so let's start. Okay, Hindi lectures will be taken separately on the channel which is GATE Wallah MECE and XE channel, so don't worry. Okay, this channel is basically dedicated for South Indian students or those students who are only comfortable in English. So don't worry, you will be getting Hindi lectures on your GATE Wallah MECE channel. Okay, that channel is purely in English, Hindi, so you can go there. Okay, now, so let's solve this question. So the average surface flow of a reservoir in the month of June is 20 kilometer square. Okay, so a reservoir, you know what reservoir is? Whenever we obstruct the flow of a river with the help of a dam or something, or any impounding reservoir, you will see that behind that dam or wall we will have huge amount of storage of water. That is nothing but reservoir. Okay, the surface area in the starting is 20 kilometer square. Okay, in the same month, average rate of inflow is 10 meter cube per second and outflow rate is 15 meter cube per second. Okay sir, now monthly rainfall is 10 centimeter. That means amount of rainfall which is being received in the month of June is nothing but 10 centimeter, which is given in the question, and monthly seepage loss is 1.8 centimeter. The storage change is 16 million meter cube. The evaporation in that month is how much? That we have to simply evaluate. So this is again a question of basic water budget equation. Let me help you, and you also help me. With the help of basic water budget equation, we have to solve it. So you all know that equation is what? Inflow minus outflow equals delta S. Okay, some things are given to you, and one thing we have to find out, that we'll solve. Okay, So this is our water budget equation. Now what are the components that are coming in? See, this is your reservoir. Let us say this is my reservoir and some things are coming. Okay, yes or no? Okay, now what are the components that are coming as inflow? This is the amount of water which is being stored here. So firstly is inflow. Inflow is coming at the rate of 10 meter cube per second. See, we have to evaluate for a month. Okay, if we want to evaluate for a month, so first evaluate that in a month how many days, how many hours, how many minutes and how many seconds are there. Let me tell you, it's very simple. You all know that in 1 month, basically in 1 month 30 days are there. You all know this. Okay, and in 30 days you all know in one day we have 24 hours. Everyone knows this. Okay, so we'll multiply it by 24. Okay, so and in every hour you have 60 minutes and in every minute you have 60 seconds. So this is the amount of seconds which we have in 1 month. If you will solve it, let me solve it on calculator. See, this is very simple. You should remember this value 2592000. If I'm not mistaken, this answer will be 2592000. You can also check. Okay, and in single day we have 86400 second. Okay, 24 hour multiplied by 60 by 60 is 86400. These numbers you should remember. Okay, so I hope this is correct. Okay, so in a month we have these amount of seconds. Understood, sir? Now, so in the inflow part, see, 10 meter cube per second water is flowing. 10 meter cube water is flowing inside every second. Then in entire month, how much will be the total volume of water which is getting inside? Sir, I will multiply it by 2592000 seconds. Okay, this is the total amount of volume. See, I already told you I into delta T. Okay, you have to multiply discharge by time in order to get the total volume. It's very simple. So we have multiplied it here and this is the amount of volume which we are getting here. Okay, total amount of volume is what? 10 into 2592000 meter cube. This will be the volume which is getting inside every month. Okay, basic, namely June, because they are saying in the month of June. Now, secondly, what else is coming inside? You can see here. Yes, rainfall is 10 centimeter. Now, see, this is depth of. See, convert this depth into meter first. Say 10 centimeter. You all know we have to convert it in meter. We have to divide by 100. And what is the area? Multiply this depth by area. Area is 20 kilometer square. So when you will multiply depth by area, you will get the volume. 20 kilometer square. See, kilometer, you all know 1000 meter. You know, in 1 kilometer 1000 meter is there. Square it. 1000 square is 10 power 6. 1000 square is 10 power 6 meter square. Okay, so this is the amount of volume which is getting inside your reservoir in the month of June, in a single month. Yes or no? It's simple. I hope it is clear to you. Yes or no? Perfect. This is simple. Now, what else is going out? Sir, outflow. Let me check. The outflow rate is 15 meter cube per second. So we have to subtract 15 meter cube water is going out of the system every day. Okay, let us assume it is leaking inside ground or somewhere else. Okay, but from this reservoir 15 meter cube water every second is leaking out. Okay, and if this process continues for entire month, how much volume of water will leak out? We can simply evaluate by multiplying. Okay, what else is going out? Seepage loss is there. Seepage loss is how much, sir? 1.8 centimeter. Okay, let me write it here. What else is going out? Sir, 1.8 centimeter, when I will convert into meter, this will be this, multiply by area, so that we get the volume. I hope this is clear to you. You all know how to convert kilometer square into meter square. This is very simple. Simply you have to convert the units. And what else? Evaporation is happening. Okay, they are saying, in this question they are saying find the evaporation. This question has been asked in GATE examination previously. Okay, in past year papers this has been asked. Okay, so evaporation we have to evaluate, and which is equal to what? Which is equal to delta S. Delta S is also given to us. See, in this question they are saying after 1 month, okay, after 1 month you will see that this level will change, storage will change, and you will see that 16 million meter cube water may have added or it may have been decreased. Okay, it can be, it depends, that we will discuss whether we have to put this 16 million meter cube here in positive sign with a positive sign or a negative sign. Okay, that we can judge by simply evaluating this. Okay, now when I will solve this, question, you have to Simply evaluate it. 10 into 2592,000 plus 0.1 into 20. So when you will solve this number is coming out to be 2.792 in 27.92, sorry, 27.92 into 10 power 6 meter cube, this bracket. Then we will solve this bracket. Okay, this we are getting it as 259,230 plus 0.018 into this is, when you will add this will is coming out to be 39.24. 39.24 into 10 power 6 meter cube, and we have minus E because evaporation is getting lost, equals delta S. Okay, this equation we have, and we have to simply evaluate evaporation. Okay, I hope this is clear to you all. Yes, perfect. Yes, you are solving with me, that's great. Now you all know, tell me, I am simply asking a very simple question. Tell me, when you will solve this, will you get this thing in negative or positive? Can you tell me? See, this number is less and this number is more. See, negative term here is more and positive term is less. So obviously when you will sum it up, the algebraic sum which you will get here is, tell me, the algebraic sum, this much logic you can apply. Okay, this much logic you can apply. Yes or no? So this algebraic sum, when you will solve, it will be absolutely in negative. Yes, Sushil, you are absolutely correct. This will be in negative. Yes, sir. So it means this delta S which you have to put here should be in negative, because in this case it is not saying that it is decreasing. In this case, in this question, it is saying it is changing. So change can be of two types. Change can be positive also, it can increase also, it can decrease also. But what we have to take, that we have to judge. Okay, that we have to infer by our own sense. Okay, so here I will say, when you will solve this, okay, when you will subtract them, 27.92 minus 39.24, when you will solve this, you will get it minus 11.32. Or, and you all know 10 power 6 is nothing but million only. 10 power 6 is nothing but million only. Okay, that's why I'm putting it in 10 power 6 minus E equals, this we have to put in negative. So this is minus 16 million. Million means 10 power 6 meter cube. Okay, so from here you can evaluate E. So simply take transpose or simply transfer in there, and you will get it as, how much value of evaporation we are getting here? Tell me how much value of evaporation we are getting here. Can you tell me? So we are simply getting the value of evaporation as, tell me how much we are getting. Yes, this is coming out to be 4.68. This will go here, this will come here. So it is coming out to be 4.68. Evaporation which we are getting here is 4.68 million meter cube. This is the amount of volume of water which is being lost in form of evaporation in the entire month. It's a huge amount. Okay, we have to save it. We should try to save it. Okay, 4.68 is a huge amount. But in this question, they are saying find the evaporation in centimeters. But you have evaluated evaporation in volume, meter cube. Now what we have to do? We have to simply divide this volume by area. Okay, simply divide this volume by area. Area is what? 20 kilometer square. Okay, area is what? 20 kilometer square. So now you will get the answer in, divide this. Okay, divide this by 20, you will get it as 0.234 meter. Or simply if you will convert into centimeters, this will be 23.4 centimeter. Yes or no? It's very simple. So 23.4 is the answer. 23.4 centimeter will be the answer. This is the amount of, you can say, evaporation that is taking place in this entire month of June. Yes or no? Perfect. So are you now confident in solving such type of questions in GATE examination? Because this question has been asked once. Okay, so I hope this question must have given you some confidence in solving some water budget questions. Because see, this question was little tricky, because in this question they are not mentioning exactly whether the storage has increased or decreased. So accordingly that you have to evaluate. Okay, so I hope this is clear to you. Now we have some more questions. Okay, we'll discuss them and after that we'll proceed. Okay, so next question is next question is, we have 1 hour rainfall of 10 centimeter magnitude at a station which has a written period of 50 years. See, this is again a question of gate examination, but since we have not discussed written period, okay, I have not told you about written period, that we'll discuss in precipitation chapter. So after discussing written period topic, we'll come back to this question. Okay, so let's leave it. Now, again, we have one more beautiful question here. And in this question, it is saying rainfall intensity is 20 mm per hour. Okay. So rainfall intensity is given to us as 20 mm per hour. That means in a single hour, how much amount of depth of rainfall is happening in this area? 20 mm. Okay, this is given to us. And this is happening in a duration of 6 hours. Okay, so duration of rainfall is 6 hours. That is also given to us. Okay, you can see here. Then the area in which this thing is happening is 100 hectares. Okay, this much amount of rainfall has fallen on this area, 100 hectare area. Yes or no? Now, the measured direct runoff volume in the stream draining the watershed was found to be 30,000 meter cube. I already told you, see, rainfall generally falls in an area, and whatever water will fall in that area, whatever water will fall in that basin or catchment area, you know that all the water will ultimately drain into the central stream. Okay, all the water will ultimately drain into the central stream, which is lying at the lowest level. Okay, which is lying at the valley line. Yes or no? So I hope this is very, very clear to you. So ultimately, all the water is draining into the central stream, and they are saying it. They are saying it in the question that the total direct runoff volume is nothing but 30,000 meter cube. So runoff volume is given to you. Now, the precipitation available to runoff in this case is how much? Okay, not available. See, this is a question which is based on simplified water jet equation. Okay, what was our simplified water jet equation? I already told you that losses is equal to what? They are asking what is the amount of precipitation that is not able to run off. That means, let us assume X amount of rainfall has happened, but out of that X amount, some water will be abstracted, some water will be lost. Sir, where? Either it may have infiltrated, or it may have evaporated or transpired, or be it any kind of loss, depression, storage, varga, be it any kind. But after precipitation, some water must have lost. Some water, sir, must have lost, and because of that, you will see that only some portion will run off. Okay, or part of it, a portion of it will run off. So, sir, simply you are saying that out of total precipitation, we have to subtract runoff in order to evaluate the losses. This was our simplified water budget equations. I hope you remember it. Yes or no? So now you have to simply find what the losses, which is the demand of this question. So now firstly we have to evaluate. See, this is the final equation which we have to use. Now firstly we have to evaluate precipitation and runoff. Okay, so precipitation is how much? Total amount of volume of water which has occurred on this area that we have to evaluate. So total volume of rainfall first we have to evaluate. Okay, so total volume will be how much? See, 20 mm. 20 mm rainfall is happening in every hour. So in 6 hours, how much rainfall will happen? Can you tell me? Multiply it. Okay, in 1 hour 20. So in 6 hours it will be how much? In 6 hours it will be 120 mm. Yes or no? This is very simple. Multiply this. In 1 hour 20 mm rainfall is there. So in 6 hours 120 mm will be there. Yes or no? Convert this 120 mm into meters. Okay, you all know that when I will convert mm into meter, we have to simply divide it by 1000. You all know this. In 1 milli means what? 10 power minus 3. Yes or no? I hope you all agree with this. So this is the depth of rainfall. This is the depth of rainfall which has occurred in this catchment area. Now multiplied by area. Area is what? 100 hectare. 1 hectare is 10,000 meter square. You all know this. You have to remember that 1 hectare is 10,000 meter square. Yes or no? Yes or no? I hope this is clear. Multiply it. How much we are getting? Yes, 1,20,000. Yes, perfect. I can see your comments. The answer is absolutely correct. 1,20,000 meter cube is the total amount of precipitation. So can you tell me the losses? Now can you evaluate the losses? Therefore the losses, or you can say therefore the part of precipitation which is not available for runoff is how much? Can you evaluate that? Now this will be P minus runoff. This will be P minus runoff. P is what? 1,20,000 minus 1,20,000 minus your runoff. Runoff is how much? So runoff is simply 30,000, which is given here in the question. Okay. That data has already been given to us. So simply subtract it, you will get it as how much? This is coming out to be 90,000. That means out of total 1,20,000, 90,000 has been lost. Simply it has been lost in form of evaporation, or be it any other loss, depression, storage, varga, any kind of loss it can be. But this is a huge amount of volume. Okay. Approximately you can say. You can also find the runoff coefficient here. But the answer is not matching because you have to find these losses in depth. And this is the volume which you have found out. So if you want to convert your volume into depth, what we have to do? We have to simply divide by area. This we have already discussed. Okay. So convert this losses into depth. Simply divide volume by area. Okay. Volume by area. Volume, I hope, is very, very clear to you how we have found out. Area is how much? Area is given to us as 100 hectares. So 100 hectare you will convert into meter square. You all know 1 hectare is 10 power 4 meter square. Simply divide it. You will get it as 0.09. 4 zeros will get cancelled. Yes, 0.09 meter this is. So when you will convert into centimeter, it will be 9 centimeter. You all know 1 meter is equal to 100 centimeter multiplied by 100 to get 9 centimeter. Okay, A option is correct here. I hope this is clear to you. Can you find the runoff coefficient here? Can anyone in the comment box tell me what is the runoff coefficient here? It has not been asked, but let me check if you remember runoff coefficient or not. Can you solve it? Can you solve the value of runoff coefficient? The value of runoff coefficient, can you solve? See, runoff coefficient is what? Runoff upon rainfall. Runoff in this case is how much? Runoff in this case is how much? The runoff in this case is 30,000. 30,000 divided by total rainfall is 1,20,000. So 30,000 upon 1,20,000 is what? 30,000 upon 1,20,000 is what? 0.25. That means out of total rainfall, only 25% has been converted into runoff. Yes or no? So I hope this part is very, very clear to you. Okay. Now we'll move on to the next question. I hope this is clear. 0.25. That means 25%. Out of the total rainfall, 25% rainfall has been converted. Now let's move on to the next question. So in this question, they are saying consider some statements. Consider the ratio of runoff to annual precipitation as R0. Okay. See, this is your runoff coefficient. Runoff coefficient is what? Runoff upon annual precipitation is simply your runoff coefficient. Just now why I have made you solve runoff coefficient in the last question, because you have to have the idea about runoff coefficient. Okay. It depends on what type of land we have. Okay. It depends on the land use pattern. Now, for all the continents on earth, you all know that there are 7 basic continents on planet earth. You all know this globally. So some statements are there. The very first question, it is saying Asia has the largest runoff coefficient, Europe has the smallest value of runoff coefficient, Africa has the smallest value, or Australia have a smallest value. How you will decide this? Like which continent has more runoff coefficient, which continent has? See, you need to understand one thing. Whenever consider rural versus urban area. Okay, let us imagine we have urban area in which more development is there, huge amount of concreting has taken place already, and let us consider an area which is not so developed, which is rural area. Okay, can you tell me if same amount of rainfall happens in both the areas, same amount of rainfall, where infiltration will be more? Can you tell me? Obviously it is very simple. Infiltration will be more in rural areas because not too much of development is there, and all the water which will fall will ultimately drain into the ground. Yes or no? But that will not be the case. But that will not be the case with urban area. Yes or no? Because sir, in urban area, sir, you know, roads will be there, buildings will be there. They will obstruct the flow of water from going into the ground or penetrating into the ground, and all the water will ultimately run off into the drains. You will see more runoff will be there. So in urban areas, you know that runoff is more. Wherever development is more, okay, I hope you can understand or relate to development. Okay, Yes or no? Wherever development is more, you will see more runoff is there and infiltration is less in urban areas basically, and in rural areas where development is not much, where you have more open areas, all the water will infiltrate inside and runoff will be less. Yes or no? I hope this concept is clear to you. So now can you tell me where runoff coefficient will be more? If R0 is your runoff coefficient, so obviously runoff coefficient is more in urban areas. Yes or no? Can you tell me? Yes or no? Can you tell me? Runoff coefficient will be more in urban areas and runoff will be less in rural areas. So if same amount of rainfall happens in both the areas, you will see runoff is more in urban areas, but it is less in rural areas. Okay. Now based on this knowledge, which I have told you right now, can you guess or infer what will be the correct option here? Now amongst Asia, Europe, Africa and Australia, which is the least developed, which is the least, or you can say underdeveloped nation? Can you, nation is not the correct word here, continent. Can you tell me which is the least developed amongst Asia, Europe, Africa and Australia? Yes, Africa. Yes, perfect. Africa is the least developed. That means amount of contributing will not be that much, which is present there in Europe, Asia and Australia. Okay, so obviously in Africa, you all know it is a kind of, you can say, area which is rural, because there is not too much of development, so runoff will be less, so runoff coefficient will be smallest. That's why C option will be correct here. Okay. Europe being developed, okay, Europe was developed from a very long time already, so in Europe, development is too much, so runoff will be high, runoff will be more, so this is wrong statement. Asia is having the largest value, no. North America is even more developed than Asia, so North America will be having the largest value. North America is having actually the highest value, and Africa is having the smallest value. I hope this is clear to you, how you have to how you have to guess the answer to this question. I have told you the exact logic behind it. Okay, I hope this is clear to you. Perfect. Okay, now let's move on to one more question here. One more question has been asked here. So in this question it is saying, yes, so in this question it is saying a watershed has an area of 300 hectares. Okay, due to 10 centimeter rainfall event over the watershed, a stream flow is generated at the outlet of a watershed which lasts for 10 hours. See, this type of question we have already solved. In this question it is saying, sir, we have a catchment area, okay, and in that catchment area we have a central stream, and in this central stream water is flowing after rainfall for 10 hours. Rainfall has happened, and after that rainfall, sir, water is continuously flowing in this river for 10 hours. They are saying stream flow is generated at the outlet of watershed. Okay, because of all the stream flow at the outlet, this is your outlet point, you will see that continuously for 10 hours water is flowing. Okay, water is flowing continuously. Understood, sir? Now catchment area is how much? Catchment area is 300 hectare. This is also given to us. Due to 10 centimeter rainfall, okay, rainfall is 10 centimeter. Assuming runoff rainfall ratio is this much, what will be the average flow? Now for 10 hours, what discharge you will see here? For 10 hours, what discharge, what flow you will see, that we have to evaluate. So before solving it, what we have to do, first we have to find the total volume of runoff. Now what will be the volume of runoff? If I want to evaluate volume of runoff, how you will evaluate it? Can you tell me? See, volume of runoff, if you want to find, first you have to find the volume of rainfall. First you have to find the volume of rainfall, then multiply it by runoff coefficient, 20%, 25%, whatever is given to you, that will be runoff. Yes or no? So what I have to do here, first I have to evaluate the volume of rainfall. So volume of rainfall is very simple, multiply area by depth. Area by depth, you will get the volume. So area is what? 300 hectares. This is your area. Yes or no? Depth is how much? Depth is how much? 10 centimeter. Simply 10 by 100 meter. Yes or no? 10 centimeter is your depth into runoff coefficient, runoff rainfall ratio, which is 0.2. See, this is the total volume of rainfall. You all know that runoff coefficient is runoff upon rainfall. I have already told you. So rainfall you have evaluated multiplied by 0.2, you will get runoff. Out of total rainfall, only 20% is getting converted into runoff. Out of total rainfall, only 20% is getting converted into, only 20% is getting converted into, only 20% is getting converted into runoff. Okay, so this is volume of runoff. This is volume of runoff. Okay, so multiply this, how much you are getting, multiply this, how much you are getting. So let me also solve it. So this, see, 30 into 2 is nothing but 60, I guess. Okay, this we can simply evaluate. 1 0 will go here, or see, those two will get cancelled, this will get cancelled with this one, only 10 power 4, so 60,000, I guess. Okay, this is simple calculation. So 60,000 is the amount of water which is passing from here slowly and steadily in 10 hours. Okay, so if you want to find the discharge, if you want to find the discharge at outlet, what is the total amount of volume which is passing? See, this is volume of direct runoff. Okay, this is volume of direct runoff, this is volume of direct runoff divided by total time duration. So see, but in this question they are saying to evaluate in meter cube per second, meter cube per minute, meter cube per hour. So first we will evaluate in meter cube per hour, then we'll convert hour into minute, we'll get it in meter cube per minute, that also will solve, and then we'll convert minute into second, that will also solve. So first let us solve in meter cube per hour. So the volume of direct runoff is how much? The volume of direct runoff is 60,000. The volume of direct runoff is what? 60,000 meter cube divided by time. Time is how much? 10 hours. Okay, for 10 hours this flow is happening. So when you will solve it, you will get it as 6,000. Yes or no? 6,000 meter cube per hour. This 10 and 10 will get cancelled. So 6,000 meter cube per hour. This is 60,000. It is 6,000. So this is wrong. This is wrong. This is not the exact flow. Yes or no? Yes or no? Perfect. Now, after this they are saying convert this into meter cube per minute. You all know that in 1 hour we have 60 minutes. You all know this. Okay, in 1 hour we have 60 minutes. So 6,000 divided by 1 hour. 1 hour is nothing but 60 minutes. So if I want to evaluate in meter cube, see, when you will divide this, you will get it as 100. Okay, this is nothing but 100 meter cube per minute. So if you will check it, 100 meter cube per minute will be absolutely correct. So this is correct answer. Convert this minute into second also. Convert this minute into second. You all know that in 1 minute we have 60 seconds. You all know this. Okay, divided by 60. You will get it as divided. This is simple. 5 by 3 in table of 20. So this is 1.67. 5 by 3 is what? 1.67 meter cube per second. So 1.67. This is 16. This is not 1.67. So they're trying to. This is also wrong, and this is also wrong. If it would have been 1.67, then it would have been right. But C option is correct here. I hope this is clear to you. Very simple question. Perfect. C option is correct. Very good, Sushil, Kiran, Ankit, everyone. Perfect. So I hope with the help of this question you are able to understand the entire concept of your runoff. Okay, these questions are basically dealing with concept of runoff. Now last question, after which we will start our next chapter, precipitation. So in this question it is saying in the hydrological cycle the average residence time of water. Okay, they are asking about residence time here. So see, residence time means what? See, residence time is a very simple concept. Let me explain it to you. Residence time has a formula. The meaning of residence time is for how much duration of time for how much duration of time water has actually stayed in any phase of water cycle. Okay, let us imagine oceans. Okay, in oceans you all know that water stays for some time. So what is the amount of time for which water has stayed, or you can say resided? You know, residence means living there. So how much amount of time water has actually lived up there, that we have to evaluate. We have a formula for that, which is volume of water in that phase volume of water in that hydrological phase, in any hydrological phase such as oceans. You all know that water stays there for sometimes in oceans, sometimes it is in clouds, for sometimes it is in soil, for sometimes it is in river, and it keeps on moving. It keeps on moving, but it lives at some places for more time, in some places for less time. So how we will compare that, we have to evaluate. So residence time is what? Volume water in any hydrological cycle divided by the average flow, divided by the average outflow rate. You all must appreciate the fact. Let us try to understand this concept very beautifully. You will appreciate the fact. Let us say in this box we have total 100 meter cube water, and 2 meter cube water every day is getting evaporated from the system. So can you tell me what is the residence time of the system? So total we have how much water? 100 meter cube. Total we have how much water? 100 meter cube. And 2 meter cube water is leaving the system every day. So how much is the residence time of this water? Can you evaluate? Can you evaluate? Yes or no? Can you comment down? Everyone try to comment down and tell me what is the exact residence time here. So the total volume is 100 meter cube and the average outflow rate is 2 meter cube per day. So when we will solve this, you will get 50 days. In total 50 days, you will see that all the water will go out. Or you can simply say that any drop of water is living here for approximately 50 days. Not more than that. Yes or no? Not more than that. Yes, Krim, you are absolutely correct. I hope this concept is clear to you. Similarly, we have some moisture present in atmosphere. Similarly, we have some water present in all the rivers of the world. Similarly, we have some water which is present in the ground. Similarly, we have some water present in oceans, rivers, groundwater, like that. So how I will evaluate residence time? How I will see? I told you that in the you all know that 13,186 million kilometer cube water is there present in the world, out of which 3% is fresh water. So evaluate 3%. Out of this 3% fresh water, 70% is in frozen form and 30% is in ground. So evaluate 3% of this, then 30% of this. So you will get the total volume of groundwater. You will get the total volume of groundwater. Then divide by the average flow rate. Then divide by the average outflow rate. You will evaluate the residence time of groundwater. Yes or no? If you know the total volume and if you know the total average outflow rate, okay, then you can evaluate residence time for each and every one. See, this is a detailed factual data are very detailed that you cannot remember. So obviously I'm just trying to tell you how you can evaluate the residence time of global groundwater. Simply put the volume of entire groundwater which is present in the entire world and simply divide by average outflow rate. You will get the residence time. So can you guess which will be having the highest amount of residence time? Sir, obviously the phase in which volume of water is too much. When volume of water is very high, then obviously your residence time will be high. Yes or no? It depends on two things. Where volume is more and what is the outflow rate. If outflow rate is less, then obviously water will live there for more time. Yes or no? So it depends. So obviously residence time will be maximum in oceans. Okay, basically it is more in oceans. Yes or no? So you have to remember this. Then in groundwater. Sir, why? Because you told us in the very beginning that 97% water is in oceans. Then out of remaining 3%, out of that 3%, 30% is in groundwater and 70% is frozen. And remaining 0.3% was surface sources. In surface only 2% was rivers. So river water is very less. River water is basically very less. So residence time of groundwater is too much. Residence time of groundwater is more. Yes or no? So oceans, you need to understand, in oceans we have more water. That's why residence time is very high than groundwater. Then we have lakes. Lakes also have too much of water as compared to rivers. Okay. If we talk of surface sources, lake is around 87% and river is only about 2%, and 11 is your wetlands. I already told you this data. Yes or no? I hope you remember that global water distribution table which I have already showed you today also. So this is the pattern of, or you can say this is the order of your residence time in various phases. Now based on this, and atmospheric moisture will be even less. Why? Because sir, in atmosphere we have very less water. Because in atmosphere we have very less water. That's why the residence time will be even low. Yes or no? So based on this, now can you infer the answer? Now can you guess the answer? Now can you tell me ABCD which answer is most appropriate here? Can you tell me? Kindly comment everyone. So based on this data, based on this explanation we have, see the first option is atmospheric moisture is having larger residence time than that in global rivers. No. Atmospheric pressure is at last, so obviously it is having lesser residence time. Yes or no? Perfect. Yes, everyone is giving answer as D. Perfect. Great. D is the correct answer. Why? Because this is wrong. So atmospheric moisture residence time is less. So this is wrong. Oceans is smaller. No. Ocean is having larger residence time. So this is also wrong. River is larger. No. River is having a smaller residence time than groundwater. So that is also wrong. And ocean is having larger residence time than that of global groundwater. That is also correct. D option is absolutely correct here. I hope you have understood this. Very simple. Now we'll move ahead. Now we'll proceed further with our chapter number 2, which is nothing but your precipitation. So now we have to understand the causes of precipitation, basically why basically precipitation happens, the scientific reason that now we have to understand. So what precipitation exactly is, why it happens. Basically there are two main factors. Okay, basically there are two main factors for precipitation that we have to understand. So we have to first try to understand that entire atmosphere has a certain capacity to store moisture. Okay, atmosphere collectively has a certain upper limit, or you can say has a saturation point below beyond which it cannot store moisture. Everything has a certain limit, or you can say certain upper limit up to which it can store. Yes or no? Do you agree with me? Imagine a glass of imagine a simple glass in which you have a limit to fill the water. Okay, if you will exceed that limit, obviously water will overflow and water will spill out. Yes or no? So every container, every glass, or every kind of bottle, or this atmosphere also has a certain limit, to hold the moisture. Yes or no? Understood, sir. So see, the amount of moisture, the amount of vapor, the amount of water vapor which is actually present in the atmosphere is measured by a term called vapor pressure. Okay, you all know that in atmosphere, in this air, we have too many gases. We have nitrogen, we have oxygen. You all know nitrogen is in maximum quantity. You all know this, around 78%. You must have studied from basic class. Okay, nitrogen is in maximum quantity, oxygen is around 21%, remaining we have carbon dioxide, we have neon, we have some inert gases. This you all know. Okay, we have water vapor also. See, every gas which is present in air, exerts pressure. Yes or no? Every gas exerts pressure, possess some volume. Yes or no? You all know this. This is basic concepts of physics and chemistry that we are not going to discuss, but let me tell you that every gas which is present in a system exerts a pressure. Similarly, if water vapor are there, if moisture is there, that will also exert a pressure. Yes or no? That is vapor pressure. Now you should appreciate the fact, if more is the vapor pressure, that means more amount of water vapors are there, more amount of moisture is there. Yes or no? If in my atmosphere more water vapor are there, more moisture is there, then obviously vapor pressure will be more. And if moisture is less, then vapor pressure will be less. This is very simple. Okay, so I hope this is clear to you. So now I will use the term vapor pressure. See, vapor pressure, now I will use or you can simply say I will use vapor pressure and moisture interchangeably. Moisture and vapor pressure is one and the same for me, because more the moisture, more will be the pressure that will be exerted by water vapors in the atmosphere. Okay, so vapor pressure or moisture are one and the same here. Okay, so now when your atmosphere is fully saturated. Now when your atmosphere is fully saturated, or you can say completely filled with moisture, at that time the vapor pressure will be highest. Yes or no? Can you appreciate this fact? Whenever your entire atmosphere is completely filled with the moisture, then you should appreciate that at that time the vapor pressure will be maximum. Yes or no? Are you with me? So obviously at that time the vapor pressure is known as saturation vapor pressure. Saturation vapor pressure is what? When your moisture is at maximum level. If I am going to increase vapors beyond this level, if I am going to increase moisture beyond this level, then what will happen? Can you guess what will happen? Then obviously that water will spill out, and you will see fog is there. You will see clouds have formed, or you will see formation of mist is there. Okay, why in winter season all this fog, mist, and all these things happen? Because your vapor pressure or the amount of moisture exceeds that critical limit, exceeds that saturation value. If it will go beyond saturation, then obviously it will condense out. Yes or no? Kindly comment yes if you have understood this concept. So I will write one or two points here. You need to understand. You have to understand these points. If whenever your vapor pressure is more, or it exactly, more is not the correct word, equals or greater than, okay, because vapor pressure uh, when it reaches the maximum level, then obviously after that it will start spilling out. Whenever your vapor pressure is greater than or equal to saturation vapor pressure, this is the maximum value. Whenever actual moisture is trying to exceed this limit, then obviously at that time what will happen? Condensation will start. Condensation means that water vapor, the water which is present in gaseous state, sir, it will get converted into liquid state. Yes or no? Perfect. Whenever more moisture is there in the atmosphere, more vapors are there in the atmosphere, at that time I will see that condensation happens. Yes or no? Condensation or precipitation will occur. But sir, what is the other case? What is the other side? Okay, other side is whenever moisture is less. Okay, whenever your atmosphere is dry, whenever your moisture or vapor pressure is less, okay, less than maximum value, less than saturation you can understand. SVP is what? Saturation vapor pressure. S means saturation. So whenever your vapors are less than the atmosphere holding capacity, at that time you all know that it will not get condensed. At that time atmosphere can hold more moisture, so more evaporation will happen from the planet earth. Okay, or globally you will see more evaporation will happen in dry seasons. In summer seasons you all must have witnessed that clothes dry faster. Yes or no? Cloth dries in the summer season at a more rapid rate. Why? Because evaporation is there. So if this gap is too much, or simply we can say if atmosphere is dry, or simply moisture, whenever moisture is less, when atmosphere is dry, whenever moisture is less than saturation value, then obviously more water will get evaporated. At that time more and more water will get evaporated and will try to saturate the atmosphere. Yes or no? Perfect. Okay, evaporation is more, but why precipitation decreases year by year? See, precipitation is not decreasing year by year, pattern is getting changed. Okay, some places you get less rainfall, but at some places you will see more rainfall. Cycle, you can say cycle balance is disturbed, okay, because of human activities. That will not discuss now because it will take another half an hour for me to explain that. Okay, let us stick to the topic. Let us focus on the topics which will be asked in gate examination as of now. Okay, so I hope these things are clear to you. So if now someone asks you like why precipitation happens, you will say, sir, when more humidity, more moisture, more vapors are present in the atmosphere, and whenever it will try to exceed the saturation limit, whenever it will go beyond that critical limit, or whenever it will try to cross it, at that time, sir, you will see that precipitation or rainfall will happen. Yes or no? I hope this is clear to you. Okay, now let me show you one very beautiful graph here. Okay, you will understand that easily, not so tough. See, atmosphere holding capacity, which I am referring to as saturation vapor pressure, saturation vapor pressure. See, atmosphere has a certain limit. Atmosphere has a certain upper limit to hold the moisture. Yes or no? Perfect, sir. That saturation vapor pressure, that holding capacity depends on temperature. Sir, what you have said just now? The saturation vapor pressure, the highest amount of moisture which atmosphere can hold, the maximum amount of moisture or vapors that atmosphere can hold depends on temperature. That means if let me show you the graph first. See, this is the graph exactly. Basically, this is the kind of graph. So it means at higher temperature, atmosphere has more ability to hold moisture. But at lower temperature, it cannot hold more moisture. At lower temperatures, you are seeing here in the graph that at lower temperatures, the saturation vapor pressure or the maximum amount of moisture or the maximum amount of humidity that it can accommodate is less. Yes or no? That means capacity is less at a lower temperature and it is capacity is more at a higher temperature. I hope you can understand this. Because of this phenomena, because of this physical phenomena, you need to understand. Let us take an example. Imagine at 30 degrees Celsius, saturation vapor pressure is equal. Saturation vapor pressure is denoted by EW. Okay. Saturation vapor pressure is denoted by EW. EW stands for saturation vapor pressure. So let us imagine that at 30 degrees Celsius, at a given temperature, 30 degrees Celsius, the saturation vapor pressure. So pressure is measured in mm of Hg. Let us take an example. Okay, 2 mm of Hg is too much. Okay, because maximum it can be 1. No, maximum it can be at 76 point. How much? 13.6 or 76.4? Okay, that will not discuss. Okay, so just imagine that at full capacity, we have 1 millimeter of mercury pressure. Okay, but actually in the atmosphere, we have less moisture. See, maximum this much amount of moisture can be there, but in actual we have only 0.4, or let us imagine, yes, let us imagine 0.4. So can you tell me how much is the amount of deficit, or how much is the amount of water that can evaporate right now? Sir, obviously you can see this is the amount of saturation deficit here. See, this much amount of moisture can be held by atmosphere beyond this point, because some places is still left, some capacity of atmosphere is still not being utilized. So I will say this is what? This is saturation deficit. This is saturation deficit. Yes or no? Yes or no? Perfect. No, saturation vapor and atmospheric pressure are not same. Obviously atmospheric pressure is more, Kiran. Why? Because in atmosphere you have more gases, not only water vapor, not only vapor pressure. Yes or no? Yes or no, Kiran? Sir, you have to understand that in atmosphere we have water vapor as a very small component, not more than 1%. Okay, even less than 1% water vapor we have, but we have nitrogen, we have oxygen. See, atmospheric pressure is what? Pressure is what? Force upon area. Force of what? Weight of these gases. You all know that above your head we have a huge column of air which is consisting of nitrogen, oxygen, water vapor and everything. So obviously the amount of pressure which it is exerting on us is atmospheric pressure, or simply the weight of these gases. The weight of these gases above us divided by unit area and get the pressure. That is atmospheric pressure. So obviously atmospheric pressure is more. That's why I didn't took it as 76. You all know that 76 mm of Hg or 13.6 mm of Hg is the torrential pressure. I hope you have studied this concept. I hope this is clear to you, Kiran. This concept is clear to you that atmospheric pressure is more and vapor pressure is obviously less, because we have more gases in atmosphere. Okay, some are heavier, some are lighter. So this is what? This is saturation deficit. If someone asks you like what is saturation deficit, you will say EW minus EA. Saturation vapor pressure minus actual vapor pressure. The more the difference in maximum and actual value, the higher will be the rate of evaporation. Yes or no? The faster the water will get evaporated in order to fill this gap. Yes or no? Yes or no? Simple. So now let us take a case. Let us take a case. Just imagine that in atmosphere we have this much amount of vapor pressure. Understood? Now just imagine temperature has started to fall. Okay, temperature is getting down on hourly basis or with passage of time. Temperature is getting down. Okay, now when temperature is going down, actually vapor pressure is not changing. Actual vapor pressure is not changing, that is 0.4, that is fixed. Okay, but you should appreciate the fact that whenever temperature is going down, sir, the capacity to hold moisture, the ability to hold moisture is getting down. The ability to hold moisture is getting down. Now initially at 30 degrees Celsius the capacity was 1, but just imagine that at 5 degrees Celsius, just imagine that capacity at 5 degrees Celsius is 0.4. Try to imagine. Okay, here saturation vapor pressure is 0.4. Now try to understand that at 30 degree whatever was actual vapor pressure is saturation vapor pressure as 5 degrees Celsius. Now you should appreciate that at 5 degrees Celsius actual vapor pressure and saturation vapor pressure are equated, or you can say have almost become equal. But at 30 degrees Celsius, sir, saturation vapor pressure was more. We have more space in atmosphere. We have more deficiency in atmosphere, or you can say holding capacity was too much. Here holding capacity is less. So now you should appreciate that it is 5 degrees Celsius at a lower temperature. What will happen? Sir, I will see condensation will start happening. Yes or no? Condensation will start to occur, and you will see that at 5 degrees Celsius fog is there, cloud formation is there. You know that in hilly stations, or whenever you must have seen whenever temperature is too low, you must have seen that cloud formation is there and you are not able to see the sun. You must have seen this. Okay, in winter season generally what happens, fog is there, dense fog is there. Fog is what? Mist is what? Cloud formation is what? It is nothing but condensation only. It is precipitation. Precipitation, condensation are I'm using it interchangeably, but it's not exactly correct, but condensation is the right word. Whatever water vapor is present, whatever water vapor will be present there will get condensed out in the form of fog, mist or clouds. Yes or no? I hope this concept is clear to you. So ultimately, sir, you are saying that whenever temperature is going down, saturation vapor pressure or holding capacity of moisture in the atmosphere is going on decreasing. That is written here. When temperature decreases, saturation vapor pressure also decreases. Okay, when temperature decreases, holding capacity of atmosphere goes down. I hope this is clear to you. So I hope these two statements are clear to you. So ultimately, if someone asks you like what are the causes of precipitation, if someone ultimately asks you, say, what are the causes of precipitation, I will simply say, if someone asks me what is the cause of precipitation, can you tell me? I have explained it to you beautifully. I have tried my best so that you are able to understand the concept. Okay, can you tell me what is the exact cause of precipitation? Now, have you understood or not? Yes, obviously, Ankit, evaporation will not occur. See, Ankit, you need to understand it's a dynamic process. What is the meaning of dynamic? Here, Ankit, you need to understand. Let us imagine a beaker is here. Okay, and this is water. Okay, just try to understand, Ankit. See, at the surface, some molecules will gain too much of kinetic energy because of the temperature and they will leave. Those molecules of water which will leave the surface, we are simply saying they are getting evaporated. Some water vapor molecules or moisture must be roaming here and there near the surface, and when they will come near the surface, they will get caught into the surface. So some water will get condensed and some water molecules gets evaporated every time. But you need to appreciate the fact that sometimes evaporation is more and condensation is less, and sometimes condensation is more, evaporation is less. So it is a dynamic process. Dynamic means both the processes are happening simultaneously each and every time at all the temperatures at any given time. Both the processes are happening. But if you will see the overall result, if this level of water is going down, then obviously evaporation is more. In net, we will say evaporation is happening. I hope, Ankit, this concept is clear to you. So exactly evaporation will not occur is not the correct term. Okay, evaporation is happening, but it is happening at such a lower rate in winters evaporation happens, but it happens it's at such a low rate that even our clothes does not dry up. Okay, it happens, but it happens at a very lower rate. Overall, in net resultant, you will see that evaporation is not happening. Overall, you will see in 1 second 2 drops of water has gone, but in that same second 10 drops of water have collected back, condensed back, then obviously you will see no net evaporation is there. Okay, so I hope the concept is clear to you, Ankit. Is it clear? Is it clear to you? Kindly comment, then we will discuss the causes of precipitation. I hope till here everything is clear to you. Okay, now what are the causes of precipitation? Can you tell me? You have to tell here. You have to tell. I have already explained the entire thing. Check this slide again. What things or what parameters or what factors you can think which are responsible for precipitation or condensation? Can you tell me? Before moving further, let me also throw some light on humidity term. Humidity simply is vapors only. If more is the amount of atmospheric moisture, we say atmosphere is more humid. Yes or no? Perfect. Absolutely correct. Decrease in saturation vapor pressure. Perfect. And more moist. See, two very simple things. Absolutely correct. Two simple things are there. When more humidity, when more moisture is there, when humidity, when moisture or simply vapors are getting increased, when humidity moisture is getting increased, then I will say a condition can happen when vapor pressure can exceed the maximum value or saturation value, then your precipitation can happen. Otherwise, we have to lower the temperature, or simply we have second factor when temperature goes down. When temperature goes down, okay. So wherever temperature of that surrounding or water vapor will go down, then I will say that saturation. See, because of this temperature going down, you need to understand that saturation vapor pressure decreases, and when this saturation vapor pressure will decrease, automatically your vapor pressure will be more than saturation vapor pressure because it is going down. Okay, so because of this you will see precipitation will happen. Ultimately, if vapor pressure is getting exceeded than maximum value, then you will see condensation starts to happen. Okay, this is the ultimate thing. Very simple concept. I hope you have understood this. Now we have one more term. You are guessing it absolutely correct. Okay, decrease in temperature, and secondly, more moisture, more humidity. More is the moisture. You must have seen one article in newspaper, or you must have read this term, relative humidity. Okay, relative humidity is a term which is basically the ratio of actual vapor pressure and saturation vapor pressure at a given temperature. At any given temperature, at any given temperature, okay, at any given temperature, the ratio of actual vapor pressure and saturation vapor pressure is your relative humidity. Simply, if you want to understand relative humidity, it is nothing but actual upon saturation. Let us say actual, see, at this point of time, the example which we took here, maximum is 1, but actually we have 0.4 mm of mercury here. So you need to understand that out of total 1, only 0.4 amount of moisture is there. So 40% here. Okay, simply we can say 40% is our relative humidity, 0.4. Okay, per 100 it is 40, or simply 0.4. Out of 1 it is 0.4. So 40% is our relative humidity. That means relative humidity is little less. If this relative humidity or simply your actual vapor pressure will go on increasing, obviously rainfall will happen. Okay, if this relative humidity increases beyond 80, 90, 100, then you will see if it is more near to 1, then you will see that both of them are same, then vapor pressure will become equal to saturation pressure. At that time you will see precipitation starts to happen. Okay, so in newspaper you must have seen that relative humidity term is there. So whenever relative humidity will be more than 100%, then you will see precipitation starts to happen. I hope this concept is clear to you, because at that time the atmosphere is completely saturated by moisture. At that time atmosphere is completely filled, or you can say saturated with moisture, and more amount of moisture will cause it to spill out. Okay, but how to find actual vapor pressure? See, it's a method, there is no need to understand that. Okay, see, we are studying hydrology here. Okay, so stick to the basics only, which things which can be asked in exams. I'm already explaining it to you. I'm already explaining too much. Okay, that is which is not required, so let's not dive that deep. Okay, so wait a second first. Yes, so this is your relative humidity. But yes, one more thing, actual vapor pressure and saturation vapor pressure both should be measured at the same temperature. You should not do this thing that actual vapor pressure you have evaluated at different temperature and saturation at different temperature. Okay, and how to measure vapor pressure, you all know that barometer is the instrument. Okay, many things are there that you need to skip here, Sushil. Okay, actual vapor pressure can be evaluated by many instruments, okay, or any techniques. Okay, that's a part of chemistry that we, or physics, that we don't have to discuss. Okay, how to measure pressure. So I hope precipitation causes are fully clear to you. I hope by now causes of precipitation are fully clear to you all, like why it happens basically. Okay, why thing is fully clear to you. Now after this we will move on to what are the types of precipitation. Okay, what are the types of precipitation, after this we have to discuss that. Now see, basically 4 types are there. Okay, wait a second. Yes, crystal clear. Basically what I mean to say here is basically 4 types are there. Okay, basically 4 types of precipitation are there. The first one is, see, in all the types, you need to understand, in all the types of precipitation, one thing is common. Either vapor pressure will increase or temperature will go down. Anyhow, okay, in all the cases, you will see that at the end, temperature is going down somehow or the other. And because of this temperature going down, you will see that cloud will start to form. And when the cloud will also gather too much of moisture, it will start to fall. Ultimately, this is the basic cause. See, 4 uh, types of precipitation we have to understand. The very first one is your convective precipitation. Okay, this is the first one. Let me not number it. So try to imagine we have a land mass. Okay, we have a land mass. Okay, sir. See, convective precipitation basically occurs in those areas, which have a very high temperature, such as the areas which are lying in the tropical region or near the equator. You all know this, that this is our planet Earth. This is equator, this is tropic of Cancer, this is tropic of Capricorn. You all know this. See, this is a region which is receiving sunlight directly, and obviously you all know this, in this area uh, daily in the noon time rainfall is there. Sir, why it is happening? Because you need to understand, because of the sunlight, this land mass will get heated up. Understood, sir? This land mass, or you need to understand, the air which is in contact with this land also gets heated up. And warm air, you all know that warm air will rise up. Yes or no? So warm air will rise up. Yes or no? Are you with me in this? Sir, warm air basically rises up. Warm air will ultimately rise up. Why, sir, this is happening? This is happening, sir, because of extreme temperature. Yes or no? So ultimately warm air will rise up. Now when this warm air rises up, what happens? This air basically expands. It starts expanding. Okay, you need to understand. Okay, so at places which is near the equator, we are witnessing huge amount of temperature, and that because of that air gets heated up. And light air, you all know, when air gets heated up, it is warm and it is having lesser density, so it will rise. Now you need to appreciate the fact when it will start rising. Okay, what I'm saying, yes, let me write here also. Warm air, or you can say hot air, being lighter, rises up. Okay, being lighter, rise. See, before explaining this to you, let me explain the concept of convection. I hope you know what is convection. See, try to imagine a jar in which you must have made tea in the morning sometimes. Okay, I am just guessing, you must have made tea or something like that, tea or coffee, whatever it is. Imagine we have a burner here. Okay, imagine we have a flame. This is your flame, and you have you are trying to boil some amount of water. Okay, so this amount of water. So what happens basically in this container? Basically, what happens in this container? You need to understand. See, firstly, this burner or flame will, what it will do, it will warm this water, or it will heat up the water which is near the flame. Yes or no? So this water which is present in contact with, or you can say is near the flame, it will get heated up first. Now when it is heated up, it expands and becomes lighter, and when it will become lighter, you will see what will happen. This water which is near, see, this water is hot, this water has now become light because it is heated up. So this water will start moving up. Okay, this water will start moving up. Understood, sir? Because it is lighter. So now when this water will start moving up, this water will be pushed downwards from the sides. Why, sir? Because the upper water is colder. Upper water is comparatively colder and it is dense. It is having more weight. So it will go down, and the lighter water which is heated up will go upwards. Yes or no? So colder water will come down, but lighter water, heated up water will go up. Yes or no? Then again, this cold water which is now coming in the contact of flame will get heated up. Again the process will start. So this is how a convection current has started to form. Okay, convection currents set up, and because of this convection currents, you will see that entire water gets heated up. Okay, first the lower layer will get heated up, then the upper layer will come down, and then it will get heated up. Again that it will get lighter, it will go up, again the colder water will come, and in this process, in this manner, in this fashion, you will see that entire water gets heated up. So this is a concept of convection. I hope you must have studied this in your 9th class. Okay, this is a concept which we study generally in earlier classes. Okay, in primary classes. So this is your concept of convection. Similar, in a similar way, in a similar fashion, this is happening at equators basically, because at equators land mass gets heated up, and the air which is near to your, okay, try to understand, this is flame. Okay, this is flame, similar to the example of your tea. Okay, this is your flame which is very very hot, so land mass is hot. This is your water, lighter water, the water which has just heated up is going up, and when this water will go up, obviously in this area no water will be there, no air will be there, it will be low pressure area. Okay, and because of which you will see that air from side will start coming inside. Wait a second. Yes, air from sides will start coming inside. Yes or no? Air from side which is colder will start coming inside. Again, when this air will rise, the air from the side which is more cold will start coming inside, and again it will get heated up. Then it will also go up again. Okay, again it will get heat up, it will go, it will start rising, again more air will come, that will also get heated up, again it will start rising. So like this you will see convection currents start to set up. Okay, in this area you will see that convection currents are set up. Convection currents are set up. Now if someone asks you, sir, why these currents are set up, you will simply say, sir, these currents are set up only because of the temperature difference. Okay, temperature difference is the basic cause which you have to remember here. Yes or no? Will you remember this? That in convective precipitation, because of too much of temperature difference, or you can say simply because of very high temperature, okay, of land mass and air, sir, this convection currents have set up. Now this air which is going upwards is expanding. Warm air being lighter rises up, but it expands. Adiabatically. What is the meaning of this? See, adiabatic means there is no exchange of heat from the surroundings. That means where this air which is lighter and more, you can say, is at high temperature because it is heated up, but it will not lose its heat energy to the environment. No exchange of energy will be there because it's an adiabatic process. But you need to understand, since it is rising up and expanding, when this will expand, when this air will expand, in expansion process it has to work, and when it will work, it has to consume energy of its own. the internal energy of the system will start decreasing because it has to work for expansion, and because of that temperature will go down. And when temperature will go down, you will see clouds will start to form. Okay, you will see clouds will start forming in this area. Yes or no? So when this warm air which is lighter rises up, it expands adiabatically. It expands adiabatically to form clouds. Okay, it expands and forms clouds, and obviously you all know clouds is nothing but a form of condensation, a form of precipitation. Okay, is this thing clear to you? So in this fashion you have convective rainfall. Now when cloud will form, obviously more and more air will come. Okay, moisture will be continuously stored in this, and when it will be saturate, cloud will give you rainfall. Okay, so such type of precipitation is what? Such type of precipitation which is happening because of temperature difference is nothing but your convective precipitation. So ultimately what happened, sir? Warm air was there, it went up, temperature went down. And sir, whenever temperature will go down, sir, you already told me, whenever temperature will go down, sir, precipitation will happen. Okay, precipitation will happen. We have some other forms also. I hope this is very clear to you. Okay, so at equators you must have witnessed, or you must have read it somewhere, that at equators daily, around in the noon time, okay, around 2 p.m. to 3 p.m, daily rainfall is there. Why? Because in equators sun is exactly over the head, more heat is there. Whenever more heat is there in the start morning time, 10 a.m, 11 a.m and 12 p.m, around that time, more and more air goes upwards. Okay, and around 1 p.m to 2 p.m you will see clouds will start forming. Okay, and that clouds basically, ultimately rainfall happens around 3 p.m, 4 p.m, 2 p.m, like that, depends how much heat is there. So daily you will see at equator, daily this convection cycle goes on, and more precipitation and more rainfall is there at equators. You must have seen equator. At equator we have different kind of vegetation there. Okay, forests are very thick at equator. Okay, why? Because more and more rainfall is there. I hope this is clear to you. So it's a concept, but let's not go there. So I hope the convective precipitation thing is fully clear to you. Now we have orographic precipitation. See, what is orographic precipitation? So it's a very simple concept. Let us imagine a mountain. Okay, let us imagine a mountain or some feature like that. Okay, so just imagine we have a ocean here. Okay, imagine we have a ocean or any kind of water body here. Just try to imagine. Understood, sir? Now what will happen? See, whenever winds will start moving over these oceans, what will happen, sir? Whenever, sir, wind will start moving over, whenever wind will start to move over these oceans or seas or any kind of river or any kind of water body, it will start picking up moisture from there. Okay, these winds are moisture laden winds. These winds are moisture laden winds. What does it mean, sir? These winds have picked up, or you can say simply gained, too much of moisture when the water has passed over oceans. Why? See, because over oceans, seas, river body, any kind of water body, you will see that uh, the area which is in the vicinity, or the atmosphere in the vicinity, will be having more moisture, will be more humid. You must have seen that whenever you visit some river or any kind of lake, in that area you will feel more humidity. Why? Because in that area more evaporation has happened, and when this winds will come, they will pick up the moisture, they will pick up the water vapors from there. Now this air, when it will move from oceans to land masses, and let us imagine it has been obstructed by any kind of orographic barrier such as hill. Okay, this is a kind of orographic barrier. Okay, so let me write down the basic definition here. Whenever moisture laden winds, okay, whenever or when moisture laden winds, when moisture, see, this is moisture laden winds, whenever moisture laden winds are forced to move up, whenever moisture laden winds are forced to move up, okay, forced to move up across any orographic barrier, across any orographic barrier such as a small hill, mountain, like that, across any orographic barrier. You can see here, you should appreciate the fact that these winds, now there is no option but to go up. There is no other option for these winds but to go up. Now when they will climb the mountain, now when they will go up, okay, what will happen? You will see that temperature will start dropping. You all know that at higher temperatures, temperature at higher altitude, sorry, at higher altitudes temperature starts dropping. Now you all know that whenever temperature will drop, saturation vapor pressure will go down. Yes or no? This I have already told you. Saturation vapor pressure will go down. Understood, sir? Now when saturation vapor pressure will go down, obviously these water vapors will be in excess quantity because atmosphere moisture holding capacity has gone down because of lower temperature. At higher altitudes, atmosphere does not have too much of capacity. So obviously what will happen? Sir, condensation will happen. Yes or no? Condensation or precipitation will start to happen, and you will see that in this area cloud will start forming and rainfall will start to happen. And see, rainfall will basically happen in that area where from where these winds have climbed up. Okay, this side is known as windward side. This side of mountain or hill is known as windward side because windward, because wind is climbing the mountain from this side only, and all the rainfall will happen in this side only. See, now when these airs when this air will move further, now it would have become dry. Why? Because all the water, all the moisture, it has shed in the windward side, and on the back side you will see no rainfall is there. Why? Because that air is dry. Yes or no? That is the back side, which is the leeward side, or leeward side is nothing but rain shadow zone. Leeward side will not receive rainfall. Why? Because, sir, it is not having moisture. All the moisture has been shed in the front side. Yes or no? Why it is called rain shadow zone? Because no moisture has been carried away by the air. Air has already dropped all the water. Yes or no? So this is orographic precipitation. So when moisture laden winds are forced to move up across any orographic barrier, okay, any orographic barrier such as any kind of hill, okay, any kind of hill, mountain, like that, then precipitation occurs. Towards windward side. Precipitation occurs towards windward side because temperature goes down. Okay, when temperature goes down, you all know, whenever temperature goes down, you all know that saturation vapor pressure goes down, and because of that we have more relative humidity. So this is a kind of, ultimately in orographic precipitation we have orographic barriers such as hill, mountain, like that. I hope this is clear to you. Okay, now the next one which we have here is cyclonic precipitation. See, in cyclone basically happens because of pressure difference. Okay, cyclone basically happens because of pressure difference. You have to remember this thing. Okay, it's a very important. Cyclone basically happens because of pressure difference. See what happens. Imagine an area which has been heated up and air has been lost from there because warm air rises up. You all know this. So in that area, deficiency of air is there. It's a low pressure region. Okay, that area is known as low pressure region. Let us try to imagine this is a low pressure region, and you all know wherever there is less air, air tries to come from sides. Okay, let me draw it here. Try to imagine this is a low pressure area and air is trying to rush from all the sides inside. Okay, whenever air is trying to come inside from all the sides, and because of this severe pressure difference, see, this is an area of high pressure, this is an area of low pressure. Air flows from high pressure to low pressure. You all know this. Okay, basic physics, physical phenomena. So whenever air is trying to come from high pressure to low pressure area from all the sides, and somehow it starts to develop circular motion. Okay, like this you will see here. Okay, like this, if it starts whirling around or surround. See, you must have seen this in summer season, that wherever dust particles are there, you must have seen some whirling motion or swirling motion is starting to form because of pressure difference. Okay, so whenever air rushes or gushes in from high pressure area to low pressure area, you will see that this kind of circular motion basically develops. So this is nothing but cyclone only. Okay, so when air moves from high pressure to low pressure region, or simply what is cyclone? Because of this, you will see, because of this, you will circular motion, you will see that air starts to develop circular motion, okay, like this. And when it starts to develop circular motion, all the air which is coming inside will start moving up like this. Okay, you must have seen this. Air which comes inside starts to move up in a circular fashion, and when it will move up, temperature will go down. When temperature will go down, again at the top you will see that formation of clouds are there and rainfall starts to happen. Okay, rainfall basically falls in this entire area. Okay, but simply you need to understand, whenever this air which is swirling, or you can say air which is moving in circular fashion, circular motion is going up, and because of going up, temperature is going down, and temperature, whenever temperature falls, precipitation happens. Okay, so basically you need to remember that because of pressure difference, cyclone happens, and whenever cyclones are there, you will see cyclones are basically accompanied by precipitation. Okay, so you need to remember the direction of cyclones, which is very important. See, in northern hemisphere, see, you all know that earth has been divided into two halves. One is the north part and the next one is your southern part. Okay, so in north part, and we have two phenomena, one is your cyclone and one is your anticyclones are not so important, but still I will tell you the direction because it's opposite of cyclone only. See, in cyclone, you know what is there? In cyclone, at the eye, at the center, we have low pressure. So obviously in cyclone, air comes from outwards to inwards, from high pressure to low pressure. In anticyclone, it is opposite. In anticyclone, at the center we have high pressure and air will be moving out. Okay, so this is anticyclone, just opposite of cyclone. Many other differences are also there. Anticyclones are less, you can say, less violent or less rainfall with, you can say, they are more calm as compared to cyclones. So the directions first you have to remember. See, basically cyclones in northern hemisphere rotates in anti-clockwise direction, counterclockwise direction, anti-clockwise direction. You all know what anti-clockwise is, opposite to that of clock. Okay, in southern hemisphere it is clockwise. See, opposite, see, you have to remember one, and opposite will be in the next hemisphere. Okay, then anticyclone is in, see, if this is anti-clockwise, so this will be clockwise. Clockwise, you all know, in sync to clock or the direction of clock itself, and here it will be anti-clockwise. See, remember the first one, just do opposite everywhere and you will get the answer. This is anti-clockwise. Okay, so I hope this is clear to you. So you can remember the directions also. Okay, you can remember the directions. One question has been framed in GATE in past year, which is asking about the directions of cyclone. So I hope with this table never ever you will get confused so as to what is the direction of cyclone in northern hemisphere. Okay, remember that cyclone is a low pressure region. If someone asks you like what is cyclone, you will say it's a low pressure region in which it's a low pressure region. See, at the center we have low pressure with circular wind motion. Okay, it's a low pressure region with circular wind motion. I have too much of details in cyclone, but it's not important. Okay, we have to only follow that much which is relevant to our syllabus. Okay, so this is nothing but your cyclone. So I hope this kind of precipitation is also clear to you. Yes or no? Time is up, so we will end our lecture today. Only one more is left, which is nothing but your frontal precipitation. Okay, frontal is also there. Let us finish that also. See, whenever cold and hot air or warm air meets, at that time you will see that precipitation starts to happen. See, in this diagram we have cold air, we have warm air. Whenever they will collide, you will see that at the collision only. See, this is a front. Front means the imaginary line or imaginary surface where they have collided. At the front means the imaginary surface. So at front you will see, where they have collided, you will see precipitation will start to happen. You can see in this image, and immediately rainfall will happen. You must have seen that whenever you pull out a very cold chilled bottle out of your refrigerator, you must have seen small water droplets have formed on that surface. You must have seen that. Why? Because bottle is very cold and the atmosphere is warm. So because warm and cold are getting in touch, that warm air, or you can say hot air, is getting in touch with the cold bottle, immediately all the water vapor has condensed out. Similarly here you can say cloud formation will be there, and too much of thunder will also be listened. So I hope this is very clear to you. So whenever warm and cold air comes in contact, at that time also you will see precipitation starts to happen. So ultimately we have four types of precipitation. The first one was a convective, okay, in which convective cycle was there. Then we have cyclones, because of cyclonic motion rainfall is happening. Then we have this frontal precipitation, and one was your orographic barrier, in which moisture laden winds are being forced up to move through mountain barriers. Then also precipitation happens. Ultimately what happens? Ultimately temperature goes down and saturation vapor pressure also goes down, so atmosphere moisture holding capacity decreases and immediately rainfall happens. Ultimately that is the case. So I hope this is very clear to you. So these are all the types of precipitation which we have studied today. Okay, so we'll catch up tomorrow, and tomorrow we'll proceed further with some more beautiful topics. Tomorrow we'll cover all the forms. See, types of precipitation we have covered today. Tomorrow we'll start forms of precipitation. We will study all the measurement part, how we measure precipitation and why we are interested in measuring, that I will tell you yesterday. So I hope till here everything is fully clear to you. So if you don't have any doubts, let's end the lecture and we'll catch up tomorrow. Okay. So one doubt is here, sir, suggest how to effectively practice PYQ. See, if you want to practice PYQs effectively, simply you have to do nothing. Simply first study the chapters. Okay, chapter by chapter solve PYQs. Okay, whenever you are studying any subject, in that subject you are finishing chapters on daily or some basis. Okay, let us say you are finishing one chapter in 2 days. So after 2 days, when you have finished the chapters, revise your chapter completely and solve the PYQs, and whatever new things you are getting in PYQs, star mark those questions, rate it. Okay, some are tough, some are easy, some are moderate, and whatever things you are getting new in previous year questions, you must note it down in your copies. That is the ultimate thing, and after few days you have to revise it again and again. Okay, so this is the ultimate thing. So good night everyone, we'll catch up tomorrow. Stay blessed, take care, stay happy, no need to worry. Until I'm there, I will make sure that you are become champion in hydrology. Okay, so we'll catch up tomorrow. See you live at 10 p.m. Okay, take care.